Alright, so today, as I said, we're going to be looking at the length of an arc, not the measure of it, which is how many degrees, but the length of it if you were to actually figure out how long that part of the circle is. So to do that, we are going to be modifying the circumference formula to find just part of it. So we'll review circumference first. The circumference, remember, is like the perimeter. It is the distance around a circle. It's not called perimeter because perimeter is all these lengths added together, and a circle is round, so you can't really add the lengths. And remember, pi is an irrational number. And if you don't have a calculator that has a pi key, you can approximate it with 3.14. But if you have the pi key, I prefer you use it because you'll be more accurate. And then we have two formulas we should review for circumference. We have pi times diameter, and we also have 2 pi times the radius. These are not to be confused with the area of a circle, which is pi r squared. We learned that back in chapter 1. So the first couple problems just ask us to find the circumference. We are going to practice leaving the answer in terms of pi, which means you're going to leave pi in your answer. Oops. Oh, I have two more vocabulary words first, I'm sorry. We have congruent circles, which this was actually on our vocab from Friday. There are two circles with congruent radii. But I put it on here because the next one, concentric circles, I wanted you to kind of compare the two vocabulary words. And you guys don't have these pictures, so if you wanted to draw them, like next to it, these are congruent circles, two circles that have the same radius. These are concentric circles, so it kind of looks like a dartboard. So there's circles within a circle. So these are two circles that lie in the same plane, and they have to have the same the same center. Their radiuses will be different, radii. And we'll see these a lot more whenever we do section 10.8, which is geometric probability. So our first two examples just ask us to find the circumference. Leave your answer in terms of pi, which means do not type it in your calculator. Your final answer will look like this, like 21 pi or 15 pi. Pi is not a unit, though, so you still have to have centimeters, feet, whatever. So this one gives me that the radius is 5. So I would probably go ahead and use my circumference formula that has radius in it. 2 pi r. So we'll have 2 times pi times 5. And you can multiply the numbers together to get 10 pi. Now for circumference, will our units be centimeters or centimeters squared? Distance around the circle. Just centimeters. Circumference is like perimeter, just the distance around, which is a plane unit. Now the next one, we see that the diameter is given to us 18. So for this one, I might use my pi d formula. That way I don't have to divide by 2 to find the radius and then double it again. So the circumference would just be 18 pi inches. Now what we're going to do the rest of the lesson is we're actually going to look at the length of an arc. So instead of finding the distance around the whole circle, we'll just find the distance around like part of it. So that is called the arc length. It is a fraction of a circle's circumference, or a portion of a circle's circumference.
Excuse interruption. Would the following students please report to the guidance department at this time?
Okay. Congruent arcs are arcs that have the same measure and are in the same circle or congruent circles. When you change the radius, you would also change the arc. Now, the formula they have here in theorem 10/10 for arc length tells you that to find the length of an arc, you're going to take the measure of that arc, which is in degrees, divide it by 360, because that's the whole circle, and then multiply that by the circumference formula. So this is a fraction of the circumference. Now, one that will work for any letters, if you prefer, is arc length, which I usually abbreviate AL, will equal the measure of the arc, which I usually just put arc, divided by 360, times 2 pi r. You also could do times pi d if you wanted to. Now, when you multiply a fraction times a non-fraction, you would have to put this over a 1. So multiply the numerators, multiply the denominators, and then simplify. All right, so we have on the back a couple examples. And are yours darkened? Okay, let me just darken my ones on the board. So these actually look, well, that one looks like the bell ringer, kind of. But I'm changing what's being asked of you. We're asked to find the length of the arc instead of the measure of the arc. Express your answer in terms of pi. So again, leave pi in your answer. So we'll use our arc length formula, which is the arc divided by 360 times 2 pi r. And if you want, you can put 2 pi r over 1, just to remind yourself. So what is the measure of arc xy? How many degrees is arc xy? No? 90. This is 90. This is also 90. So that goes in for arc. Now we have times, we could have used pi d, I guess, because we were given the diameter, but whatever. I already wrote this up here. So the diameter is 16, which means the radius is 8. So it would have 2 times pi times 8. So we have 90 over 360, which you could reduce, times 16 pi. Now it's up to you how you want to go about simplifying. You can actually multiply these together in your calculator if you'd like. You also could multiply 90 by 16 and then divide it by 360. You could also reduce 90 divided by 360 would be what fraction? 90 out of 3. 9 out of 36 would reduce to be what? 1/4. So 1/4 times 16, or 16 divided by 4, is 4 pi. And that would be inches. But again, if you wanted to in your calculator, you could actually type 90 divided by 36 as a fraction times 16. For those of you that need to. And you would just get, whoops, I forgot my 0. There we go. 4. So 4 pi inches. Now there's a chance that sometimes the fraction won't go away, so you could have a fraction in your final answer, like, I don't know, 32/67 pi over 67. Next one, we're looking for the length of xpy, which you can tell is a major arc. They actually give you the measure of the arc is 240. So again, we're using our arc length formula, which would be arc, which is 240, divided by 360, times 2, times pi, times the radius, which they tell us is 15. do I get when I multiply the fraction and the whole number together and simplify? Right. 25 centimeters. Now, if they ask you to round to the nearest tenth, then you would actually type in the pi key on your calculator and evaluate what 20 pi is. All right, the next one has a given, and then they ask us for several things. They give us the circumference is 36 pi. Find the following. So how can we find the radius if we know the circumference? We find out what the radius is. Brett?
Put 36 pi in for the circumference and then use the circumference on
Good. Plug in 36 pi for C. Make sure you plug in put the pi there with it. And then we can solve for R. So you would be undoing multiplication, which the inverse is to divide. And you can divide by 2 and pi at the same time. And so we'll get that the radius is 18. They didn't tell us units on this one, so we'll say 18 units. What would my diameter be then? Marquise?
36.
Yep, just double it. And they also want us to find the length of an arc of 150 degrees. So we're going to use the arc length formula. That's 150 divided by 360 times 2 times pi times 18, or you could just do times 36 pi, which was your pi d. And then we need to simplify that, however you prefer. If you want to reduce the fraction first, or if you just want to put the fraction in and then multiply, you should get 15 pi. They didn't tell us to leave it in terms of pi, but I just will because all the other ones did. Now the last two are actually going to give us the arc length and ask us to work backwards and find the radius or the diameter. You want to be careful not to round anything. So find the length of the following circle's radius if the highlighted arc has a length of 11.775 inches. So start out with our formula. But this time we're actually going to be plugging in what the arc length is. They've given me the arc length. How many degrees is the arc that's highlighted going to be? How many degrees is this arc going to be? Yep. 135 degrees. You have to use the fact that the whole circle is 360. And you'll subtract the part of the arc you don't want. Okay, so that goes in for arc. Now I have to solve for the radius. How do you think we should solve this? There are multiple ways to do it. Do you want to divide by 2 first? Do you want to find out what 135 over 360 is? What do you think? Do you want to multiply these together? Are you alive? Marquise?
Reduce the fraction first.
Sure, let's go ahead and reduce the fraction. And see if it comes out to be anything that we like. It's pretty. It could be a decimal. Oh, it could be a decimal. You want to do 0.375, or you can leave that as a fraction, which will be 3/8. It's up to you. Now, as long as the decimal stops, you can stop. You can write it out. Now, if it has a whole bunch of decimals, you would have to write out all those decimals, so I wouldn't. We could do 3/8. Let's go ahead and then multiply this stuff together. So we have 3/8 times 2 pi r, which would be 6 pi eighths times r. Now, normally we would undo multiplication with division, but if you divide by a fraction, it becomes kind of messy. So what can you do instead of dividing by a fraction? Right? Good, we can multiply by the reciprocal. And that's because if you divide by 6 pi eighths, you're going to have a fraction within a fraction, which is just really messy. So the reciprocal of 6 pi over 8 would be 8 over 6 pi. Now the reason we choose the reciprocal is because then everything kind of undoes one another and cancels out, just leaving us with the radius. Now what you do to this side, you have to do to this side. So on this side I have to multiply by 8 divided by 6 pi. Then we can use our calculator to do this for us. Again, if you don't have a pi key, you'll just use 3.14. And it's up to you, again, whether or not you want to multiply these together and then divide by 6 pi. Or personally, if I'm going to reach for my calculator anyways, I would just do, in parentheses, 8 divided by 6 pi. And I should probably put those in parentheses. I don't know if it'll make a difference or not. Times 11.77. And so we'll round that to be 5. Because even if I round it to here, this 9 would round that to 10. So we'll just say 5 inches. Now again, there are a lot of ways that you can solve that. Like some of you will actually just change this to a decimal, multiply that to get another decimal, and then divide by the decimal, which usually is a lot easier than doing fractions. But I will warn you that sometimes they will be repeating decimals, and therefore you'll have to leave them as fractions. So that's why I showed it this way. Alright, see if you guys can try the closure, just similar to this. This time though, be careful, you are asked to find the diameter. So if you find the radius, you have to double it at the end. So see if you can.